Hello and welcome to today's webinar, Getting Ready for the Future, Low GWP Alternatives to R-410A in the HVAC Industry, sponsored by the Chemours Company and Carrier. I'm Terry McIver, Editor-in-Chief with Contracting Business at Endeavor Business Media. To begin, let me explain how you can participate in today's presentation. First of all, if you have any technical difficulties during today's session, please put your question in the questions window and our tech experts will help you out. We recommend that you disable any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your question into the question window on the side of your screen and hit the submit button. Also, please be aware that today's session is being recorded and will be available on the Endeavor website within 24 hours. That is the Contracting Business website. You'll be notified by email when the archive is available. And one more thing, we would ask you to wait after the presentation for a brief survey that we ask you to kindly participate in. And now I'd like to introduce today's speakers. Jeff Warther is a Training and Business Development Manager at Chemours. Jeff has been working in the HVACR industry for nearly 35 years, serving different roles from service manager, territory manager, to product manager. Other companies Jeff has worked for include Carrier Corporation, Danfoss, the Heberger Corporation, and the Kroger Company. He also holds NATE certifications in both commercial refrigeration and air conditioning service. Larry Burns is a technical fellow for refrigerant systems at Carrier. In this role, Burns serves as technical lead for evaluation and development of new low GWP refrigerants and supporting technologies for compliance with legislative and regulatory activities. He has 35 years of experience in the HVAC industry, during which time he's focused on system design and development. And now we'll begin. Jeff, over to you.
All right, thanks a lot, Terry. And thanks to all of you for spending your time today to listen into our webinar. We do appreciate your attendance. Today's discussion will start by highlighting the latest regulatory updates. Then I'll spend some time explaining the definition of what an A2L refrigerant is. And finally, Larry and I will talk about R-410B refrigerant, which has been selected by Carrier as the best low GWP alternative to R-410A, not only from an equipment design perspective, but also from an installation and service perspective. All right, so let's talk about the regulations that are impacting our industry. Now, some of you listening in today have lived through a major portion of this refrigerant timeline for the air conditioning equipment. And as we look at the right side of the green box, it's hard to believe that R-410A systems were introduced in the mid-1990s, meaning we're approaching nearly 30 years of R-410A systems being installed in North America. Now, for those of us that went through that R-22 to R-410A transition, you remember the concerns of things like R-410A having nearly 50% higher operating pressures versus R-22. The difference between POE oils and mineral oil. R-410A is a blended refrigerant, which introduced terms like fractionation and glide. We had to go out and buy a ton of new service equipment due to the higher pressures associated with R-410A refrigerant. And then there was concerns over transporting and storing of the higher pressure refrigerants. I mean, these were just a few of the learnings we went through on that R-22 to R-410A journey. So as we move from the green highlighted box and into the blue box, all the issues I just discussed are not a concern because the HVAC industry has been dealing with things like POE oils and higher pressures for quite some time. And while the journey into this blue box of HFO and HFO blended refrigerants will require us learning a few new things and possibly upgrading or buying some updated service tools, many of the best practices a good contractor currently follows will be similar to what we will be doing in the future. Now, when we look at the regulatory landscape, mandates typically start at the international level and then work their way through the federal and state levels. The Montreal Protocol and Kigali Amendments are where the refrigerant regulations were first established. And most of you know on this webinar that the U.S. has still not signed the Kigali Amendment, which is generally an agreement that the country is going to do something on curbing their HFC regulations or emissions. But for the U.S., the action plan for this HFC phase down is under recently passed legislation called the AIM Act. We'll discuss more about the AIM Act on the next slide. You can see also within that federal bucket, we'll discuss EPA SNAP Rule 23, which is the list of approved refrigerants for the air conditioning segment, as well as rules for implementing these new lower GWP refrigerants into the air conditioning equipment. Finally, since the AIM Act wasn't signed until late last year, many states were taking their own initiatives and implementing their own HFC phase downs. Now, during this presentation, we're only going to focus on the California Air Resource Board, or CARB initiatives, as we expect the EPA will implement very similar values to what CARB is proposing. At the federal level, I said that the action plan of the U.S. HFC phase down is the AIM Act. Now, what the AIM Act does is it gives the EPA the authority of administering HFC transition in several ways. First, it establishes an HFC phase down schedule, which will more than likely start next year or January 1st of 2022. And you can see by the chart that this is a phase down, not a phase out, like what we just went through on HCFC refrigerants like R-410A. Now, second, it will introduce HFC management plans for such things as refrigerant recovery as well as reclaiming. And third, it establishes something called sector-based controls. Bear with me, there we go. And that's what actually CARB is proposing. So we'll talk about that very soon. And we expect the details of the EPA's plans to actually come to us in the next 30 days. Now, moving on to the state activities, here's a snapshot of CARB's proposed sector-based control for air conditioning. And as I said, we expect the EPA will follow very similar timelines as well as GWP values. Now, as you can see, there are several dates listed for the air conditioning segment, which is based on the type of equipment. Now, the equipment shown here is primarily designed around R-410A refrigerant, units designed around scrolls, maybe reciprocating or rotary type compressors. And while there are varying dates for the products, moving forward, that maximum GWP value of the refrigerant in a newly designed air conditioning piece of equipment is going to be 750. And while that maximum GWP value has been placed on the air conditioning segment, finding the lowest GWP value refrigerant like R-454B gives OEMs like Carrier the longest potential design life compared to other EPA SNAP options. There are several reasons why Carrier selected R-454B, which Larry will go into, but having the lowest GWP value is definitely one good reason to pick Chemours Opteon XL41 or R-454B refrigerant. And I just mentioned SNAP 23 options on the last slide. So within the EPA, the SNAP programs established what refrigerants can be utilized as an alternative or acceptable for specific applications. Snap Rule 23 shown here introduces substitutes for the air conditioning segment. And you can see to the far right portion of the chart under decision, the EPA says that these refrigerants can be considered acceptable subject to use conditions. Now, use conditions will be how the unit is built as well as how a system is installed. And you can see under the chart, you can see that the refrigerants listed as substitutes have an A2L classification under ASHRAE Standard 34. So let's spend some time on discussing that and what an A2L refrigerant is. Now, the chart shown on the right is from the latest ASHRAE Standard 34. Now, a couple of steps a refrigerant goes through as it's trying to enter the refrigerant market is that they will go through two evaluations, a toxicity evaluation as well as a flammability evaluation. And you can see in the gray box, a majority of the refrigerants that contractors currently utilize fall into this A1 category, meaning lower toxicity and no flame propagation under ASHRAE 34 testing. Now, refrigerants like R-22 and R-410A do have substitute refrigerants or lower GWP refrigerants like R-410A that have actually went through the ASHRAE 34 testing and still qualify as an A1 refrigerant. And these type of refrigerants would be represented as the green box shown here. However, there has not been an industry-accepted substitute refrigerant for R-410A that meets both the 750 GWP threshold and can still qualify as an A1 classification. So, to get to the lower GWP value needed for the upcoming regulations for R-410A applications, let's spend a few minutes looking at R-410A. Now, R-410A has two components, R-125, which is classified as an A1, and R-32, which is classified as an A2L. Over 30 years ago, one of the things to make that R-22 to R-410A transition the least complex as possible was to keep that A1 designation by creating a 50-50 balance of the composition. However, if the goal of the newest regulations is to have even lower GWP value refrigerants, we'll use R-454B as our next example. First, we look at the R-410A component, R-125, which actually has a GWP of roughly 3,500. And what we do is replace it with R-1234YF, which has a GWP value of under 1. Then, to match the performance of R-410A, we increase the amount of R-32. The combination of these two refrigerants make R-454B the best R-410A replacement, along with an approximately 78% GWP reduction versus R-410A. However, R-125 was what kept R-410A within that A1 classification. And since R-454B's makeup includes two A2L refrigerants, it too will be classified as an A2L refrigerant. Now, the story of an A2L refrigerant is that it exhibits nowhere near the flammability of a hydrocarbon refrigerant like R-290 or propane, which has an ASHRAE Standard 34 classification of an A3. So nearly a decade ago, ASHRAE adopted the A2L category shown here in the yellow boxes. And you may not know it, but there is equipment within the United States that is already utilizing A2L refrigerants. Many automobile manufacturers have selected R-1234YF as the refrigerant in their car air conditioning systems. And many of the new window air conditioning units have already converted to an A2L refrigerant as well. Now, The next air conditioning segment to make the change to A2L refrigerants is the largest volume. It's called the unitary sector, which includes residential split systems and light commercial package products like rooftops. Now, if any contractor has worked with A3 refrigerants or hydrocarbon refrigerants, they know the unique service procedures needed to work on that equipment. And they know it takes only a small amount of refrigerant and a very small ignition source to have an ignition event. During this webinar, we want everyone to understand that while many of the new low GWP refrigerants will carry a lower or slightly flammable label, there is a big difference between an A2L and an A3 refrigerant classification. Now, most people are familiar with the fire triangle, right? So the two components of that triangle are oxygen or air and a fuel, and in this case, we'll use refrigerant. The two components needed to be between a lower flammability limit, or LFL, and an upper flammability limit, or UFL values, to have that right concentration for flame propagation or ignition. Now, below or above these values, the refrigerant will not ignite. As an example, an A3 hydrocarbon refrigerant has an LFL value of roughly 2%, while A2L has a much higher LFL value of around 13%, which means a much larger percentage of refrigerant would have to be in that particular space to ever form a flammable concentration. And even if there was an ignition, or even if there was a situation that would allow for an A2L refrigerant to make to a flammable concentration, it's much harder to get that concentration to ignite. So an A2L design system will look a lot like the current R-410A systems because the refrigerant is much harder to ignite versus a hydrocarbon system, where even maybe the smallest amount of energy, something as small as static electricity, could ignite an A3 concentration. So let's quickly do a summary of an A2L versus an A3 refrigerant. First of all, A2L refrigerants are less likely to ever get to a flammable concentration, which will allow an A2L low GWP refrigerant to be designed into a wider variety of equipment. And even if the situation would allow for an A2L refrigerant to make it to that right concentration, it is much harder to get that concentration to ignite. Simply put, many of the electrical sources or electrical tools used in the field will not ignite an A2L refrigerant. Finally, if the refrigerant does ignite, an A2L typically exhibits a lazy flame and doesn't produce much of a heat source, where the right concentration of even the smallest amount of hydrocarbon refrigerant could produce a significant event. So before I turn it over to Larry, let's take one last look at the comparison of R-410A, R-454B. The similarities include similar pressures and temperatures, similar properties of the refrigerant, similar components like TXVs or filter dryers, similar oils, and what Larry will point out in a few minutes, similar designs of the equipment. But let's also understand the differences. The GWP value is definitely different. R-454B has roughly 1/5 the GWP value of R-410A. Then it comes down to the difference between the ASHRAE 34 refrigerant classifications, which is where Carrier will utilize the latest UL and ASHRAE 15 standards to not only design the new equipment, but update the installation and service manuals as well. Now, it's time for me to turn it over to Larry.
Thanks, Jeff, and hi, everyone. Thanks for being on today. So
Let's answer the question, why did Carrier select R-454B? Future refrigerant choice is a very big decision for us and the industry. So to support this selection, Carrier conducted significant analysis and testing of low GWP options to replace R-410A. Carrier participated in both Phase 1 and Phase 2 of the ARHRI Alternate Refrigerant Evaluation Program, or AREP, in which multiple refrigerant options were tested by multiple original equipment manufacturers. In addition, Carrier conducted significant internal performance and extended reliability testing to assess the impact of the new refrigerant options. This activity included working with key component suppliers, such as compressor manufacturers and TXV manufacturers, to assess the impact to the component design and performance. In addition, the standard materials used for system construction were evaluated for thermal stability and material compatibility with the leading refrigerant options. This material evaluation included metallic components, polymers, lubricants, and process fluids, so it was very complete and extensive. Overall, Carrier has done extensive modeling and testing of the new refrigerant options. We chose R-454B, which will be commercially known as Puron Advanced, to be used specifically in ducted residential and light commercial products because it has a low GWP for the application, good reliability and performance, and we anticipate it will have a longer design life compared to higher GWP alternatives. So let's take a deeper dive into the evaluation and qualification of R-454B. In addition to the Carrier laboratory system testing, which includes both performance and extended reliability testing, we have worked with key suppliers to test and qualify R-454B at the component level, with components such as compressors, TXV, reversing valves, and others. We are working closely with these suppliers to optimize performance of these components for R-454B. In addition, we have conducted significant component material compatibility, reliability qualification, and component testing to ensure performance and reliability for the life of the system. As a further major step, Carrier initiated an R-454B field trial consisting of more than 25 heat pump systems in the fall of 2020. This field trial is a significant step in that Carrier was one of the first to achieve UL 60335-2-40 certification to be able to install A2L systems in residential homes. These systems include a complete data acquisition system which allows for continuous 24/7 remote monitoring of the equipment. At this point, the systems have operated for nearly a year with minimal issue, but we will continue to operate these systems to validate the design and A2L safety mitigation for these products. So now let's look at the differences between R-410A and R-454B in a little more detail. R-454B performance is very similar to R-410A with slightly higher efficiency than R-410A. Discharge pressures are lower than R-410A while discharge temperatures are higher. But this increase in discharge temperature is not great enough to pose a concern to the compressor or the system. Based on our full evaluation, Carrier selected R-454B as the refrigerant to replace R-410A for its residential and light commercial equipment based on system performance, required design changes to the system, material compatibility, reliability, and of course, regulatory compliance. With a GWP of 466, R-454B should minimize the likelihood of additional refrigerant changes in the future. So now let's look at how will R-454B impact system operation. So as stated previously, R-454B is a near performance drop-in for R-410A. R-454B performance is slightly lower in capacity, but this capacity can be easily increased to match R-410A with a compressor displacement increase. The resulting R-454 system efficiency can be slightly greater than R-410A. R-454B operating pressures are lower than R-410A, so no system modifications are required based on pressure requirements. R-454B discharge temperatures are 10 to 15 degrees Fahrenheit higher than R-410A in cooling mode. However, no compressor or system design changes are required to manage the discharge temperatures. So as we turn to the impact to the technicians, there are many factors technicians will need to be aware of with this transition to a new refrigerant, some of which will be covered shortly in coming slides. We strongly recommend that technicians attend industry-sanctioned training sessions when available. We're also creating a carrier training curriculum for technicians. For carrier products, this will be coordinated through local distribution office and our commercial service organizations. So contacting them for possible training is highly encouraged. We also recommend contractors have their technicians take the North American Technical Excellence or NATE examination for the new A2L, as well as A3 refrigerants that will be used in some small appliances and refrigeration when it becomes available. The NATE certification examination will be updated to account for the new refrigerants, will be released as part of efforts underway through Air Conditioning, Heating, and Refrigeration Institute, or AHRI, to begin training the industry on these new refrigerants. So let's look deeper now. What should technicians know? First, we should note that safety standards and codes remain to be finalized. However, we have a good understanding of the likely impact of A2L refrigerants on the product and service practices. Installation and service will be very similar to today, but techs will need to be aware and trained on some differences. From a design or construction viewpoint, ignition sources will have to be isolated. New equipment will require the use of qualified joints, either braze or mechanical. A factory-installed refrigerant leak detection system will be required and to be linked to an active mitigation control. And additional labeling identifying the use of A2L refrigerants will also be required. These changes will be minor to the service technician and installer. So in a typical residential split system, the changes will consist of a new compressor, which is specifically optimized and qualified for R-454B, a new sealed contactor for use with A2L refrigerants, protective sleeves for the compressor and crankcase heater wiring, and new labels identifying the unit as an R-454B system. On the indoor side, a safety mitigation control, including a refrigerant detection sensor, will be factory installed. A new TXV will need to be optimized and qualified for R-454B, and as with the outdoor, new labeling for R-454 and A2L awareness will be required. Overall, the product changes will be minor. From an installation viewpoint, the installer will need to do a minimum area check to ensure the occupied space is adequate to disperse refrigerant in the event of a leak. In addition, technicians will need to comply with the qualified joint requirement. For carrier products, this will be the standard braze connections used today, so very minimal change. Exposed lengths of interconnecting tubing greater than 6 feet will require protection. And finally, a field pressure test is required. When servicing the equipment, the service tools will primarily be the same. However, reclaim equipment rated for A2L refrigerants will be required, and A2L recovery cylinders will be unique with left-handed threads. Overall, the impact will be very manageable, and Carrier will provide the installation and service training necessary to support a smooth transition to A2L refrigerants. And with that, I'm going to hand it back to Jeff, and he's going to talk more about installation, service, and repair. All right, thanks a lot, Larry. Yeah, here what we're looking at, you might have to go on mute, Larry. We're in the same room. So all right, there you go. So here we're looking at a comparison of installing or servicing of the HVAC equipment. Now, the newest standards show 3 things that will be required for an A2L installation versus an A1 refrigerant installation. However, what I would say, most of the industry would agree that the 3 things highlighted as required for an A2L installation should be done as a best practice with an A1 refrigerant installation. So if you're already doing the best practices within your R-410A installation and startup procedures, this transition to an A2L refrigerant is not going to be too difficult. Now, looking at service tools, it is important to point out that as contractors, you're continually updating your service tools. Some things like charging or weighing scales or simple hand tools won't change from an A1 to an A2L installation. However, as you as contractors begin updating things like recovery machines, vacuum pumps, and other service tools listed here, it would be best from this point forward to verify that they are A2L capable or compatible. And the good news is that many service equipment manufacturers already have A2L compatible equipment, which can also be utilized for the current A1 refrigerants. So once again, if you're in the market for a new piece of service equipment, I would recommend buying the A2L compliant equipment now so that the industry change in the near future will be a much smoother process. Now, from a refrigerant cylinder perspective, the A2L refrigerant cylinders will have a red band, or the entire top of the cylinder will be red. And you'll notice a change on a disposable, what we call a DAC cylinder. The industry will move from something called a rupture disc found on an A1 refrigerant cylinder to a resettable pressure disc on an A2L cylinder. That's shown here on the picture that just came up. Now, this new disc design works by if the, bear with me, if the pressure ever got too high within an A2L cylinder, the disc would only open up long enough to relieve that excess pressure and then shut or reset. Versus if an A1 refrigerant disc ruptures, all of the refrigerant is released. Now, industry information like AHRI Guideline Q has been updated and outlines the proper procedures for disposing of a disposable A2L cylinder, and that's what we're showing here in this picture. So we move to the next slide. Finally, as we wrap up our presentation from a contractor perspective, here is what we're highlighting, that A2L refrigerants will not need any special requirements for you to transport the new refrigerants in your service trucks. There's something under guidelines of materials of trade, and that materials of trade covers things like acetylene and oxygen tanks, as well as A2L refrigerants. Now, that's all Larry and I have to present. With a few minutes left, Terry, I think we'll take some questions.
Great, very good presentation. And we do have some questions that have been submitted, and so we're going to jump right in. And if you would like to submit a question, listeners, type your question into the question window on the side of your screen and hit the submit button. We'll start with a question for you, Larry. Can R-454B be a drop-in solution for the existing R-410A system?
So the short answer to that question is no, it cannot. You know, as we discussed, R-454B from a performance standpoint is a near drop-in solution. However, as Jeff described, it is an A2L refrigerant, and standards and codes require that you have the appropriate product design and mitigation included in the system. So standards and codes will not allow for retrofit of an existing system with an A2L refrigerant.
Thank you. A question for you, Jeff. What are the PPE requirements for using A2L refrigerants?
Yeah, I mean, most of the PPE is very similar to what you would be utilizing for an A1 refrigerant. The things that might be updated might be the fire extinguisher, if you've got something like that, to be a Class B type of thing. It might require some ventilation as you're doing the installation, but overall the PPE will be very similar between R-410A and R-454B.
All right, another one for you, Jeff. I think R-454B has a temperature glide. Can it still be topped off after the system leaks?
Yeah, it's a good question. Yeah, that was the thing all the way back in R-410A days, is because R-454B and R-410A are a blended refrigerant. They do have a little bit of a glide, but all the testing that's been done, you will be able to top off an R-454B system if it has a leak. The only thing that you'll have to do is, much like R-410A, we want the refrigerant to come out of that cylinder in a liquid form. So you would be inverting the refrigerant cylinder and having going into the system as a liquid, but topping off an existing R-454B system is going to be acceptable, yes.
Larry, a question for you, a couple actually. First, what type of oil can be used for the R-454B system?
Okay, R-454B is miscible and compatible with POE oils and PVE oils as is currently used with R-410A. So some of our initial work shows that in many cases we can use the existing PVE or POE oils. But ultimately, the final selection of oil will lie to, the compressor supplier, but we expect, will be either, POE or a PVE oil, and very likely the same existing oil that's used with R-410A.
All right, and then another Larry question. If any component, fan coil or condensing unit, for example, need to be replaced, does the other component need to be replaced as in a whole system changeout?
Yeah, I'm not sure I fully understand the question, but I think that the answer is when replacing a R-410A system with a R-454B system, you will need to replace both the outdoor and the indoor product. You know, the indoor product will come with a factory installed refrigerant sensor and mitigation control. So it's very important that the complete match system be installed to ensure the proper operation and safety of future product.
And another, Larry, a question. Up to what size of systems do you envision using R-454B?
Well, I think our plan is that we will use R-454B in the residential and light commercial products. So you will see 454B in the residential product split systems, and also as an option or the refrigerant of choice for our future rooftop systems.
Okay, good questions coming in. And this one would be for either of you gentlemen. What are the other OEMs using as a preferred refrigerant? When will we see R-454B in a Carrier commercial packaged equipment?
Yeah, so this is Jeff. So I think starting out, you saw the SNAP Rule 23 that listed, a handful of different refrigerants as substitute options. So, we've talked a lot about why Carrier selected 454B, because we believe it's got the longest runway, or has the lowest GWP, as well as the most close performance of 410A. So, I mean, there's going to be other OEM, possibly select one of the other options, and you have to just look at the announcements of some of the other OEMs. But the majority of the OEMs are selecting R-454B, and it's several reasons why. Like I say, lowest GWP, most closely matched R-410A performance. So, as announcements continue to be made, I think you'll see the majority of them will be 454B for several reasons. And as far as the commercial equipment, Larry, I mean, having packaged equipment, I think it's really just like you said, this scroll-based design. If it scrolls, eventually it'll end up with 454B in Carrier's portfolio, right?
Yes.
All right, we'll stay with you, Jeff, for this question from a gentleman also named Jeff. Do you know when the current residential building codes will be changed? And I presume myself that they are now in the process, be changed to allow the use of A2L refrigerants?
Yeah, I mean, I think what you're seeing a lot, Larry, are you on mute? There, sorry about that echo. So what you're seeing is there are several states that already have adopted the code. So like the state of Washington, the state of Florida, already have adopted what Larry discussed, the UL, the latest UL 2-40, as well as ASHRAE Standard 15. So there are states that could actually be permitted to do an A2L or R-454B installation. With the AIM Act that's coming up, like I say, we'll know more about that in about 30 days. I think what you'll see is it'll become much quicker, where before, prior to the AIM Act, the individual states were making a lot of decisions, and then if you're making individual decisions on HSC phase downs, then you're making individual decisions on the code adoptions. And I know like the ICC codes, if you're talking the IRC or, those type of things, they're all in process. And I would expect most of the codes, even the UMC, I think like in California, we expect probably around 2024, which would be a 2025 type of thing for the equipment to be coming out. But some states could actually do it now. Like I say, the state of Florida, state of Washington, and a few others are beginning to do some early adoptions.
And here's a somewhat related question from David. In the event of an indoor leak, how does that leak detection work? Assuming, does it include a noise, a warning of some kind?
I'm sorry, could you just repeat the question?
Sure thing. What happens in the event of a leak? How does the leak detection work? And for example, will there be like an audible noise?
Yeah, if a leak is detected, it will initiate the mitigation control, and which can take a number of actions. One is to turn on the indoor blower if it's not already running. Turning on the blower will cause the leaked refrigerant to be mixed out very quickly and with the air and into the space of the residence, and simultaneously will turn off any ignition sources, so electric heat, gas furnace, for instance. The question of an audible alarm has come up in some of the code discussions. However, it's not in the current code requirements. So stay tuned as we work to harmonize codes and bring them to fruition. We'll keep you updated on that question.
Thank you. Jeff, a question for you. With other manufacturers using R32, what will happen if a technician accidentally adds R32 to an R-454B system?
I mean, essentially, they become their own chemist, right? I mean, we talk a lot about, R22 alternatives, right? Can I mix, say, something like our MO99 with that? It's going to be the same thing with 454B and R32. You don't want to mix refrigerants. Whatever refrigerant the system is designed for is going to be the refrigerant that you need to put in. And if someone would accidentally add 32 to an R-454B system, the operating pressures and temperatures aren't going to be anywhere near what they, looking at PT charts and things like that. So they basically, created their own refrigerant. What happens, it would be hard to describe, but I mean, what could actually happen. But obviously, there would be no pressure temperature charts or anything related to a different mixture since somebody, added 32 to an R-454B system. So definitely never recommended to add, refrigerants other than the ones that the system like Carrier's designed.
Okay, a question for Larry. This comes from Clint. Will the TXVs be R54B specific, or can they work with an R-410A TXV?
Yeah, good question. TXV will be specific for R-454B. As we've noted, the properties of the refrigerants are very close. However, to fully optimize the performance of the system, both capacity and efficiency, there are some slight difference in operation of the TXV, so we will, as I said earlier, fully optimize the TXV for R-454B and our systems.
All right. Here's another for you, Larry, from Stephen. What form will the mitigation system take?
Yeah, the mitigation system will be an active control that's integrated into the control system of a residential system. So there will be a leak detection sensor that's mounted in, comes factory installed in the indoor section of the unit. And there is guidelines for testing and placement of that sensor. And it will be connected again to an active control. And if it does sense a leak, that active control will take the appropriate action, interfacing with the existing system control. I indicated earlier to turn on indoor blower and turn off other parts of the system to minimize any risk of ignition sources.
All right. This question, I'm sorry, I'll read it as it is. Can you go over the right-hand threads or left-hand threads related to the units and the refrigeration tanks?
Yeah, I can take that one. So the refrigerant tanks will have left-hand threads, and which is different from the current right-handed threads, and that's to draw attention to that these are A2L refrigerants. So it's to make awareness to the service tech that this is a different refrigerant. It is an A2L. Similar to some other things we've discussed, it's the final decision on the direction of the threads for the equipment has not been made. There is discussion within the safety standards committees to make those left-hand threads also to align with the refrigerant cylinders, but that final decision has not been made. And again, we'll continue to monitor that and keep everyone posted, and it will be included, in the training as we roll it out to the industry.
Okay. Oh, you men are answering questions very, very well, and they keep coming. Larry, will the current electronic leak detectors find leaks in the R-410B systems, or will a new leak detector be needed?
I'll hand that question off to Jeff. I think he's best positioned to answer it.
All right.
Yeah, so if you go out to the AHRI Safe Refrigerant Transition Task Force, we've actually talked with a lot of manufacturers, of leak detectors. And so it will need to be A2L compatible. So those are one of the things that, you'll need to look at each individual equipment manufacturer and be able to determine. I would say that you probably have to do an update to an A2L, being able to sniff that or smell it, but then, there's real good chances that it would be backwards compatible. So I would say that if you have an R-410A leak detector right now, that it wouldn't pick up, accurately pick up R-454B. But the big thing is like I say, if you buy equipment now and it's A2L compatible, a lot of times they're going to be backwards compatible. So hopefully things like this webinar is giving everybody an advanced enough warning to say, as you're purchasing newer tools, just make sure they're A2L compatible or compliant now, and you'll be ready for the transition in the next few years.
Okay. Looks like we have one more here for Larry. Going forward, will fan coils be available after 2025 that will replace existing 410A fan coils if the condensing units are still in good condition?
I think that's a question that I don't have the answer for. I think that will have to be something that's assessed as part of the future product offering.
All right. And then I had one myself that I had thought of when I was listening to the presentation about training. Will training be a combination of virtual and in-person events, and also perhaps in conjunction with distributors in regions?
Yeah, I think that, if you look out in the industry right now, there are a couple different A2L training programs released. I do know that the NATE is going to be releasing their A2L training very soon as well. So I think what you've got is, some really good A2L industry training programs that, a HVAC instructor could get and teach either virtually or in the classroom. But then, once the A2L products or 454B products are released, then you're going to get specific equipment training as well. So I think it's going to be a combination of those A2L training programs as well as very specific equipment training programs.
Well, thank you. Thank you both. I'm afraid we have run out of time, but this was one of the best webinars I've hosted. Certainly had the most questions of anything I've hosted, and I thank you, listeners. We thank you. And for those questions you might not have heard an answer to, we will get back to you via email. And that concludes the presentation. And on behalf of Contracting Business, I would like to thank the Chemours Company and Carrier for sponsoring today's event, and for all of you out there who have been listening. And please stand by at the end for the short survey. We appreciate if you participate in that. Thanks again, and have a great remainder of your day.